Okay, hello everyone. I wanted to go over some things with you that I went over with you today in class, and then some things you need to consider for the remaining exercises. So the first thing I went over with you guys was the difference between a null string versus a string that has zero length. So here I've declared a string Don, and I have not assigned it any value. It's null. Okay, so when I go to run this, if down is equal to null, it should say down is null. Otherwise, it should say not null. So if I go to run this, yeah, so it's null. Okay, so there's a difference between a null string versus a string that has zero length. So now if I declare it, it's not null, it's just nothing. Okay, it occupies some memory, but that memory location has nothing in it. The null just didn't occupy any memory. It was never allocated to memory. A null is never allocated to memory. So now if I do this, if I run it, it should say not null. And you can see that the length is 0. There's nothing there. But if I actually now go down, the length will be 3. Yep. So again, there is a difference between null versus 0 length. Very important. All right, so let me comment that out, and now we'll look at comparing strings here. So let me see what's in here. What do I want to compare? Oh, so I was mentioning in class today that there is a difference between comparing strings that are defined using literal or two quotes versus strings that are allocated using the new keyword. So here I have two strings, S1 hello world and S2 hello world, and basically these are they're references to the same memory location. So the way Java allocates memory to strings declared using quotation marks or literal strings is that if they're duplicates, they get the same memory address. So basically S1 and S2 points to the same memory location. All right. So if S1 double equals S2, which is not the way you want to do it, it will be equal, but that's because the memory locations, the memory address are equal. If I go S1 dot equals S2, it will be equal, but what equal does is actually compares the value in those memory locations. So it compares to see if it's equal. It will look at to see if capital H is the same as capital H, if E is the same as E, and L is the same as L, and yada yada yada. All right, so there's a difference between double equal and dot equals, but you never really want to use double equals with strings. So if I go to run this here, it's going to say yes 1 and yes 2. Okay, but understand that this double equals is really doing a different comparison. It's comparing memory locations, the value, the memory address. Okay, now if I go new string, so now I'm going to allocate, and we never really allocate strings this way or declare strings this way. Now because I'm actually creating two separate objects in memory, S1 and S2, and they'll occupy two different locations. They'll occupy two different memory locations. So now if I go to run this, S1 will double equal to S2 will not be true because now the memory addresses are different. So no 1. But what's in those memory addresses, okay, is equal. So S1 dot equals S2 comes back yes. So that's why you see you never really want to use a double equal with strings. Never do that. Bad practice. You can goof up a lot. All right, and then the last thing I want to do is talk about comparing characters. Okay, so as I mentioned to you, a character C, notice is assigned. C is assigned using a single quote, and then I have string S is equal to A, but double quote, so string literal. So again, a character is different than a string. Okay, so a character occupies 1 byte in memory, and this string here will occupy 2, the character A plus what's considered a null terminator. So I would not be able to go like if C equals S. I'm comparing a character with a string. I just would not be able to do that. But string has a character at method, and then that I could use. Okay, and because there's only one character in string S, if I go character at 0, index 0, then I can. Okay, it should print out yes, the characters are equal. So let me go up here. If I do the character test, yep, characters are equal. All right. So very important. Now, the next thing I wanted to talk about was the string builder class. The string builder class. So the textbook mentions string buffer, but you could just as well use string builder. Let's talk about string builder here. So here I'm declaring an object of type string builder SB equals no string builder. So that's how we declare objects. String builder or string buffers are mutable, which means they can grow in size or shrink if you wish. Grow or shrink. Strings can't. Once you declare them, they're done with. And so here I'm going to declare character D and assign that the value of B. And then what I'll do is I'll append to this object SB a string E and character D. Now notice here that this append method for string builder, I'm using both a string here to append and a character. In string builder class, if I go out to Java, this is the string builder class. There's one method called append, but yet there's multiple parameters. Okay, so we call that function overloading, which means you can call the same method, but what's inside the what you're passing to that method can be different. And Java would know, okay, what method to use based upon the parameter being supplied. So you can supply Boolean character. This would be an array of string. We'll look at arrays a little later. Doubles, floats, integers, long, objects, and then string. So we call that function overloading. All right. So here, so I have a string builder SB, and then I'm going to append to SB E, and then I'll append the value. I'll append D, but D has the value B. So it's going to have right now E, B, right? But what I wanted to show you is that if I do this here, okay, so index of D and D has B. So let me not append. I am not going to append D, or I'm not going to put in the character B into SB. All right, now a string has the index of method, so you can check to see if a particular character exists in a string, and this is going to be come up and hangman. So every string has the index of method, and you can test whether or not a character is in a string. So I'm going to go integer I equals SB, but notice here with SB I'm using the toString method. I cannot, okay, because I cannot do this integer J equals SB, okay, index of. So I'm just going to go right away to see if the string builder SB has index of D. Okay, now notice that I get an error there. Okay, because the thing is that with the string builder class, it's really not like a string. So if I look to see if there's an index, of well, D or has the value B, I can't do that because I have to use the toString method. Okay, I'm working with string builder, so if I go toString, now that will allow me to see if there's a character, let's see, B in string builder. All right, you have to use the toString method with string builder. So all right, so if I go integer I is equal to SB toString index of D, And notice here, I've taken out, I'm not appending character D. I'm not putting in the string builder. That should return -1 because B, I did not put character D in there. So it returns -1 index value. But now if I put B in string builder or append D, it should return 1 now because in string builder I'll have E and then I'll have B, and so B should occupy index 1. It should be the second. So yeah, 1. All right, so there. The point I wanted to make is that, and this will come up in the Hangman, is that if you're looking to see if a character exists in string builder, you better use the toString method. Okay, so index of. All right, now, so now what else I'm going to do is I'm going to append to string builder D and E. So as it is right now, because I've added E first and then I added B, append D, I'm adding B, E, B, and then I add D and I add E. Notice here I'm adding a string, I'm appending a string and a character. And again, you can do that. You can do that because the append method of string builder is overloaded. I showed you that a minute ago, it's overloaded. All right, but here right now then what exists in SB is E, B, D, E. So E was first, and then that gave me B, and then D and E. All right. And so then what I'll do is I'll call the replace method. Now the replace method is not function overloaded. If I go here, replace, integer start, integer end, and this kind of like works with this, like the substring method, right? The integer end you go up to but don't include that value. Okay, so you go starting index, ending index, but you go up to but don't include the ending index, but then you have to supply a string. Okay, it's not like append, you have to supply a string here. All right, so if I go SB replace, I'm going to replace, let's see here, B, this B, I'm going to replace the B with Z. So I start at index 1, but then I have to go 2, I go up to but don't include index 2. So if I go SB replace 1, 2, Z, and again, all of this will be important in Hangman. So now if I do this, you'll see that it has a value EZDE. EZDE rather than EBDE. Okay, so those are the important things that you'll need to know then for your exercises in this chapter. So study it well because those things will come up.